And now we have a really dynamic and sweet duo of speakers who have never presented at BSidesTLV before, but they have presented at BSides San Antonio, Texas, and BSides Munich in Germany. And I'd like to tell you a little bit about our next speakers. I would like to invite them to join me on the stage. Sarit and Ofir, please join me on the stage. Let's give them a warm welcome. And please join me here, yes. And as they get ready, they bring up their courage, give them all the love for first-time BSidesTLV speakers. We're going to bring them the chaser shots, as is the tradition. They each chose a beverage of their liking. I want to tell you that Sarit and Ofir have something in common. Cheers! They have something in common. So Ofir likes to take road trips on motorcycles, and Sarit likes to travel, which is a shame because we didn't get a lot of travel the past year. Yeah. But right now, they're going to take us on a journey into the world of the KashmirBlack Botnet. The stage is yours.
Thank you. Hi, everyone. Good morning. I hope you enjoyed your coffee break. So we hear about botnets all the time. And in this session, we will take you down the rabbit hole into our botnet investigation. We'll show you what we learned, and we'll give you a few tips for your next botnet investigation. I will start by talking about the KashmirBlack Botnet, describe its entities, and Ofir will continue and describe the operation and the DevOps behind it. But before we start, let me introduce myself, and it doesn't work. Okay, my name is Sarit, and I'm a security researcher at Imperva for the last 10 years. I mainly focus on application security, and I develop algorithms to detect and protect against attacks.
I'm Ofir, and I'm also security researcher at Imperva for the last 5 years, and focus mainly in database and web application security. And we are both very excited to be here.
Indeed.
Yeah.
So, before we dive into the bits and bytes of our research, let me introduce you with the KashmirBlack Botnet. Okay. It doesn't work. Oh. Again, sorry. I don't know what happened. Is that open? The clicker doesn't work.
Ready?
Yeah? Oh, okay. I hope it will work now. So, it all started on November 2019 and lasts 7 months, which is basically a research period of time. We discovered a botnet that infects popular CMS platforms, such as, and it doesn't work again. My first time, sorry for that. Oh, okay. So it mainly infects popular CMS platforms, such as WordPress, Drupal, Magento, in more than 60 different countries around the world. It performs millions of attacks per day on average, and we calculated that there were hundreds of thousands of bots out there participating in the botnet operation. Those bots utilize dozens of non-vulnerabilities, such as remote code execution, file upload, and many more. This session is a journey into the botnet core from the attacker point of view. So let's start. Security research investigation can sometimes be like a crime scene investigation. But our crime scene is spread all over the network with nobody in place. So we need to collect the clues and fingerprints to construct the picture of the virtual crime. A recent study in Imperva, we saw 9 million attack attempts exploiting PHP unit remote code execution. And we were wondering, why is this CVE so popular among attackers? To understand this hype, we started to analyze data from our data lake. We saw different IPs using the same payload over and over again, attacking different customers, which remind us of botnet behavior. So we decided to download the payload and dive in. And we basically started the mapping step. We saw that the botnet is updating. We analyzed the code and revealed all the entities of the botnet. And later we'll talk about it in further detail. The next step we took was Infiltrate. We saw that a botnet is updating on a regular basis, so we decided to act like a bot and gather these updates for later analysis. And finally, we played a victim. We wanted to understand the post-exploitation stage. Now let's review all those entities that play a role in this massive operation. So the KashmirBlack Botnet entities can be split into 3 groups. The first one is the KashmirBlack, the botnet infrastructure, the third-party services, and the botnet actors. Under the botnet infrastructure, we have the CNC and repositories A and B. Under the third-party services, we have GitHub, Pastebin, and Dropbox that the attacker used in order to secure the CNC, hide its traffic behind legit cloud services, and to, okay, let's move on. And under the botnet actors, we have the victim and 2 types of bots, and later I will elaborate on that. So here is the command and control. This is the entity that is responsible for the entire operation. It is located in Indonesia and has 3 main roles. It supplies attack instructions to bots, it receives attack reports from bots, and it supplies the infection script to infect the victim server. And here is a snapshot of the infection script. We can see that the attacker defines a parameter that represents a cron-top task. And this task is scheduled to run every 3 minutes, and it's written in Python. Now we can see some imports, and the attacker was using base64 encoding to obfuscate its malicious payload. Now the output of this task will be sent to dev null, so no history will be saved. In the next code block, we can see that the attacker redefines the victim cron-top tasks, and as part of this redefinition, he validates to remove all main notifications. Now, one thing to note here is that the attacker was using the combination of Perl and Python, which are both installed out of the box in many Linux systems. So this is probably will increase the probability of a successful infection. Now, let's move to the repositories. The first one, repository A, as you can see, is a printer component shopping site, which was hacked by the attacker and was used to store the communication script file between the bots and the CNC. Now, another entity is repository B, which is an educational institute that was used to store the bundles of exploit and payloads. We can see an example of the exploit and payload bundles. Actually, the attacker files, the hacker's file, are located under the CSS directory, among other CSS files used by this innocent web server. And they actually start with the in-memory prefix, and it looks like they are CSS, but they're actually zip files, hidden with the CSS extension. Now, here is also the modification date, and one great thing in this botnet is that the infrastructure is just like plug and play. The attacker can decide to add new exploit and payload bundle, just put it here under the CSS directory, and that's it. No infrastructure changes are required. Just put it and use it whenever you want. Now, another thing I want to add is that every file here represents an exploit that targets a specific vulnerability. Now, here is a partial list of CVEs that this botnet uses as part of the infection. Among them, we can see remote code execution, file upload, remote file include, and many more. This CVEs targets different widgets, plugins, and themes. And there are even a decade-old CVE from 2011 that this botnet uses in the infection process. Now, the conclusion here is that it's not necessary to use an exotic exploit in order to expand the botnet. Now, let's talk about the third-party services. The first one is GitHub, which the attacker was used as a repository to store his files. When we checked his repository, we saw crypto miners and PHP web shells, and we can say that by using GitHub, the attacker was achieving a layer of flexibility, as he can just upload another file here, another crypto, another web shell, whatever, and just use it, no changes to the infrastructure. Another entity is Pastebin, which is a website that allows anonymous users to share plain text through public posts called pastes. And those pastes was used by the attacker as part of the infection. And again, the attacker achieved a layer of flexibility, as it can just add another paste with commands or a web shell or whatever, and use it in the infection. No changes to the infrastructure. Now about Dropbox, Ofir will talk later in the presentation. It was used to secure the CNC. It was used in the upgrade process and to hide the traffic behind legit cloud services. Now, let's talk about the two types of bots we saw. The first one, the spreading bot, is a bot that constantly communicates with the CNC to receive attack instructions. Those are commands from the CNC telling him who to attack and how. And the bot was used to infect a victim server and in order to expand the botnet. Now, a victim site that was infected by a spreading bot can become one of two, a spreading bot or a pending bot. So let's talk about the pending bot. Now, a pending bot, as I said just now, it's a victim site that was infected by a spreading bot, and as a result, is under the control of the CNC, waiting for the CNC to approach and change its purpose. And actually, this is why we named it pending bot. And I will talk about the purpose in a bit. Now, I just want to add that the difference between these two is that the pending bot does not initiate communication with the CNC. Now, let's talk about the botnet scope, the infiltrate step. So the best way to learn from an organization is to be part of it. Same for learning about botnet operation. We call it the infiltrate step. So after we got familiar with all the entities of the botnet, we wanted to understand the scope of the botnet, the victims, the targets, the attacks, and the evolution. And in order to answer all those questions, we had to take a more active approach to the investigation. We learned the communication protocol between the bot and the CNC, and we mimicked it. And we actually had constant communication with the CNC to receive all those attack instructions. We gathered them all together and saved them for later analysis. Now, here is an example of a request from a spreading bot to the botnet, to the CNC, sorry, asking to get attack instructions. And we can see a special header, user agent ghost 8, that without it, the CNC will not return anything back. And we can say this is some kind of security mechanism used by the attacker to avoid unauthorized access. Someone will get its attack instructions. Now, although this is not a sophisticated security mechanism, it is a basic one to secure the CNC. Now, as a response to the request we just saw, the spreading bot will get attack instructions in JSON format. The first parameter, the script, contains the list of commands that will be executed by the spreading bot. First, it will run the kill command to download the exploit payload bundle. Sorry again. You helping me? Okay. So first, it will run the kill command to download the exploit payload bundle, which is located under the CSS directory, the one I just talked about in repository B. It will unzip the file. As we said, it's not a CSS file, it's actually a zip file. And see the password there, Adelia Putri, which is, remember this name, Ofir will talk about it later in the presentation. It will remove the file and run a Python script. The next parameter, the payload, contains the list of victim sites that will be attacked by the spreading bot. And the last parameter contains the IP or the host name that hosts all those sites. Now, so as I said just now, we impersonated a spreading bot in the botnet and had constant communication with the CNC to receive attack instructions. We asked to get those every 3 minutes. Now, we gather all these attack instructions, and we use Shodan API in order to extract the organization, the ASN, the country, the vulnerabilities, the open ports, and the installed components. We took all this data and inserted it into a database for later analysis. So let's see what we learned. So the first question we were curious about was about the target origin country. We wanted to understand if the botnet has targeted a specific country. And here is the distribution of the targets divided by country. I think it's a bit hard to see, but there are 60 different countries that this botnet targets. And it appears that the majority of the countries are located in the US. This is actually the blue part. And after we gave it a thought, we come to the conclusion that actually many servers are hosted by cloud providers. So we can say that the origin of the target doesn't necessarily reflect on the origin of the victim. Now, another question we were curious about was how the attacker finds his targets. So we believe that the attacker had some sort of a scanner that scans for potential vulnerable targets. And he was probably using Shodan or some similar service like Binary Age or something like that to search for some open ports and vulnerabilities. And then once he has those potential vulnerable targets, he may use CMS web scanners like CMS Map or WP Scan to check for specific vulnerabilities. And once he found a potential vulnerable target that he may attack, we believe that it was initiated inside a queue in the CNC for future infection. Now, when a spreading bot will ask from the CNC to get attack instructions, we believe that this target will be taken from this queue. Now, let's talk about the botnet purposes. In order to understand the purpose of the botnet, we had to become a victim ourselves. We created a CMS honeypot and attacked it with our spreading bot from the infiltration step. Then we reported back to the CNC of a successful infection, and by that, our honeypot became part of the KashmirBlack Botnet, waiting for the CNC to approach and change its purpose. Now, we saw 5 purposes for the botnet. About the first 2, we already discussed. Those are the pending and the spreading bot. So let's talk about the others. Now, as exciting purpose we observed was a crypto miner. It mines Monero coins. And while we analyzed the code, we got access to the hacker's payment address, and we could see his balance in real time. The next purpose we observed was a result of our CMS honeypot, which was converted into a clickbait bot. And once we logged into the honeypot, we were redirected to one of many clickbait sites. And the last purpose was defacement. And once we saw the defacement signature, we revealed the hacker behind the botnet. We saw that he is part of the Indonesian hacker crew, Phantom Ghost. And while searching the web, we even saw some Facebook page and many interesting stuff, but we even saw a site that sells the Phantom Ghost crew t-shirts. Now that we are familiar with all the entities, Ofir will continue and show you the entire operation in live.
Thank you, Sarit. I hope you got my back with the clicks. Hi, everyone. So, how this botnet works? It all starts when a bot exploits PHP unit remote code execution. It causes the victim server to download the infection script from the CNC and execute it. Now, the victim server will approach repository A every 3 minutes to download a fresh communication script. In this stage, we can say that the victim server is part of the KashmirBlack Botnet. Now, the victim server the newly infected bot will approach the CNC, will communicate with it to fetch attack instructions, describing who to attack and which bundle to use. It will address repository B to download the bundle, and GitHub and Pastebin to download additional payloads. GitHub and paste bin. So now the bot ready to attack the victim server, and on successful attack, it will become part of the botnet. As a last step in the process, the bot will report back to the CNC. Now that we are familiar with the operation, let's move on and describe the stages of the botnet throughout the research period, and that's it. So when we first met KashmirBlack, it had only 10 exploits and 2 payloads, pending and spreading. It concentrated only on the growth. Then infrastructure changes started to emerge to make the botnet more stable and scalable. And the last stage was the expansion. Actually, this is an ongoing stage that we saw over the entire research period. The attacker adds new exploits and payloads. So I'm going to dive into each one of the stages, starting with the growth. So when we KashmirBlack actually has an exponential growth. I'm going to explain how we came to this conclusion. We found in our traffic 285 bots attacking our customers. But this is only a portion of the bots in the botnet, since we see only traffic of our customers. So for this example, I'm going to use 300 bots for simplicity. Every bot attacks every 3 minutes. So per day, it will attack 480 targets. Our 300 bots together will attack 140,000 victims per day. Let's say that only 0.5% of the attacks are finished with successful infection. It means that tomorrow we'll have 1,000 new bots, in addition to our current new 300 bots. So by day number 7, we will have almost 500,000 bots. But the reality is a little bit different, because we know that we have limited numbers of potential of vulnerable targets. So the exponential growth will stop at some point. Now, let's move on from the growth to the stability stage. I'm going to describe the botnet evolution over the research period and the DevOps strategy that enable it to carry out its crimes. So remember that the botnet had only one repository, A and B. Once the botnet size increased, so did the load on the repositories. And since the repositories were actually legitimate sites, they couldn't be considered as reliable and permanent entities. The attacker had to take action. 3 changes were implemented in the botnet in order to fix that. So adding new entity, repository A load balancer, expand repository A, and expand repository B. There were 3 main reasons behind these changes. First, to make the botnet more dynamic and scalable, add redundancy and load balancing. The following diagram shows the old infrastructure against the new one. While in the old infrastructure, every bot will address directly repository A. In the new one, every bot will address the load balancer to get one of many repositories. To integrate this change into the botnet operation, an additional change in the botnet was required. I'm going to describe it when I will describe the upgrade process of the botnet. Now, let's talk about internal changes that were made in order to secure the botnet and the CNC operation. So the CNC is the most important component in the entire operation. Securing it is critical. Let me take you back a little bit to the steps where we infiltrated the botnet and played the victim. We created a honeypot, attacked it with our spreading bot, and reported back to the CNC. We think that the attacker grew suspicious as he performed 2 internal changes in order to avoid interfering with the botnet, around 2 days after we interact with the botnet. The changes were reporting address was changed, and bot IP tracking mechanism was added. The first change is related to the reporting address. It helps with managing bots and versions. Bot that report to the new address is a new bot. The second change is within the botnet's communication script. A simple architecture change adds the bot's IP and country while it communicates with the CNC. It helps the CNC to monitor and trace each bot in the botnet. There were 2 main reasons behind this change: to secure the botnet operation and to manage the upgrade process. So let's see how it comes to work. The changes that we described created a situation where some bots were using the new infrastructure, while others are only aware of the old one. This diagram describes the upgrade process. When an old bot communicates with the CNC without the IP tracking header, the CNC in return sends back attack instruction that instruct the bot to download the upgrade script from repository B. Once the bot executes the upgrade script, it turns into a new bot that is now aware of the new infrastructure. The newly affected the new bot will address load repository A load balancer to get in return one of many repositories. Actually, the upgrade script changes the cron tab job that Sarit mentioned earlier in the infection stage. Now, let's talk about migrating the CNC to a cloud-based service. So there are fundamental problems in the botnet architecture, since the bots are communicating directly with the CNC and the entities. Their IP is exposed, and security controls may block them. An interesting infrastructure change has evolved to solve this problem, integrating Dropbox into the operation. Now, instead of communicating with the CNC and the entities, the bots are now communicating only with Dropbox. Now, Dropbox API is being used to fetch attack instructions and to upload reports from bots. This is a big step towards camouflaging the botnet traffic, securing the CNC, and most importantly, making it difficult to trace back to the hacker behind the operation. When we discovered this change, we were very excited since we had the authorization key of the Dropbox account of the attacker. We thought to ourselves it will be very interesting to check what's going on. So we start with fetching all the files and mapping the structure of the account. The root directory that we found was Adelia P. We think that the name Adelia has some significance for the attacker because we saw it in several places during our analysis. We saw it in password, as Sarit mentioned earlier, and we saw it used in URLs inside the CNC. Actually, the full name is Adelia Putri. Putri stands for princess in Indonesian. We think that maybe Adelia is the name of the attacker, or maybe it is someone that he cares for. Next, under the root directory, we have the payload directory, which used to store attack instructions. Actually, we found 400,000 of attack instructions in place. Next, we have the loot directory, which includes only one subdirectory, NoSQL. NoSQL is one of the bundles that's used by the attacker to attack NoSQL databases with NoSQL injection. Sorry, I need 2 clicks. Yeah. And inside, we found only one report. So putting it all together, the loot directory meant to store reports from bots divided by subdirectories for each exploit bundle. So why do we have only one report? So probably the attacker was in the middle of transition, maybe in the development stage or in the testing phase. But this is another piece of the puzzle that helps us to see into the attacker's world and understand its operation. Now, by that, we close the stability stage and we move to the expansion. As I said before, the expansion stage is an ongoing process. The attacker adds new exploits on a regular basis. So the exploits actually were extended from 10 to 17. We fetched all the files, all the bundles, and we tried to map them to the affected platform. We found that most of the vulnerabilities are in generic plugins and components. Most of them are in CMS platforms. We see that more than 80% are affecting CMS platforms. So the vulnerabilities are compatible to multiple CMS platforms, and actually we found 13 different CMS platforms. In this diagram, we see that the percentage shows the distribution of vulnerabilities for each CMS platform. That's it. Let's move on to some important key features. So, botnet development is similar to application development process. We need to take into consideration some important key features in order to create a stable botnet that is here to stay. Those are stability, flexibility, and CI/CD. In order to create a stable botnet, we need to take into consideration load balancing and redundancy, enabling scalability while growing. But this is not enough. The separation of the exploits from the infrastructure enables maximum flexibility, as the attacker can add new exploits anytime. Together, those two key features are the basis of the expansion and growth. On the other side, we have the CI/CD branch, which includes version control and deployment cycles. We call it automation. Behind every massive operation, we must have an automatic process to support it. Expansion and growth cannot exist without a solid CI/CD process. Now, let's talk about the insider point of view. As a security company, we have data of hundreds of thousands of customers where we can see attacks in the wild. But it is not good enough since our data is biased by our customers. So here are a couple of advantages we got from the insider point of view. As an insider, we could see the big picture and not just a small portion of the infection. We witnessed the botnet evolution from the first row. We saw new exploits and repositories added in real time. And by analyzing the code changes, we concluded what motivated the attacker to perform such changes. We had a unique foothold into the operation that enabled us to analyze the victims from the attack instructions, extracting countries, domains, platforms, etc. The inside intelligence led us to the educated assumption that there is kind of an automated mechanism that searches for potential vulnerable targets and initiate them inside in queue in a CNC. By analyzing the exploit distribution, we concluded what types of exploits are being used, what is the frequency that they are being used, and which are more common than others. All of this information is accessible only from the insider point of view, and it is critical in order to understand the scope of the botnet and the challenges and motivations of the attacker. Now, let's have some conclusion about botnet development. So, in a botnet development, the attacker wearing multiple hats. The attacker is the DevOps, the architect, and the developer. Using of third-party services is critical part of the infrastructure, and it is not necessary to use exotic exploits in order to expand. Now, let's sum everything up. So you're probably wondering at this stage, what is the current state of the KashmirBlack Botnet? When we decided that our research has come to an end, we collected IPs, host names, hosting services, and every possible piece of information from bots, repositories, CNCN entities. And we notified the owners of the servers and the cloud providers about the malicious activity. And today, the KashmirBlack Botnet is dead, at least as we know it. We searched our data lake and we couldn't find any trace of new infection.
Sorry.
So, what we learned from botnet investigation, about botnet investigation. First, we need, data collection is essential part of the investigation, of the research. We need to search for repeating patterns in order to find our next potential botnet. We need to, then it's time to get our hands dirty and analyze the code. It can help us with mapping all the entities. Then we should start monitor everything, collect all the data and enrich it with third-party services like Shodan and VirusTotal to extract the IP and the countries, etc. We want to, then it's time to analyze all the data and search and try to understand if there is some correlation between the victims and who is the attacker. We can use honeypots in order to understand better the motivation of the attacker. Now, for the important part, I want to give you some couple of tips for your next botnet investigation. So, first, document every step in the process. Take screenshots and save the dates to construct a timeline. Save everything, just everything. You don't know when the data will not be available for you. Thank you very much for listening to our talk about KashmirBlack Botnet.
Thank you.
Feel free to ask any question, and yes, go ahead.
Very impressive, the technology that they did. Is this something that's available to many people who have this knowledge, or is it something that's like, okay, you have to go to like 8200 or China military intelligence to know it? And the second part is, people who did like this botnet, are they working for themselves, or are they hired by a criminal organization, like subcontract, okay, create me a botnet for my activity?
So regarding the identity of the attackers, we don't really know who they relate for, but we did found that they related to the Phantom Ghost crew. We couldn't find any, they are Indonesian, but we couldn't find any if they are working as part of the government or something like this.
Yeah.
And for your first question, so what do you mean by technology? So,
The knowledge that to create this botnet and develop it, is it something that many people in the world have, or is it a specialized kind of knowledge that, hey, you have to come out of military units and special technology?
actually, I don't really know to answer this question. I believe that the things that have been used here, the architecture is load balancing and stuff like this exist in everywhere. We're using it in the industry. So we just wanted to show how the attackers need to use this technology as well and this architecture to solve same problems. Any other question?
Okay.
Sorry, didn't see you. Yeah.
Wow.
Well,
I
it's
barely
very hard to hear
you.
you.
Yeah.
Do you have a microphone or something?
Yeah, come. No, I really don't hear you. If the attacker what? Oh, if the attacker patched the vulnerability after he took... I don't think that it patched the vulnerability. It just used it and... Oh, sorry. The nice person here asked if the attacker patched the vulnerability that it was just using of the server that it just took control over. So we didn't see any evidence for that. It was just using it, and like we said, it was he or she, we don't actually know, but the attacker was using the PHP unit CVE, which was used as a first initial step into the server. And we even saw that the servers was indeed vulnerable. Like we found some of them, the repositories that he was uploading the bundles of exploit payloads were still vulnerable.
Yeah, in one case, in our honeypot, we saw that actually he didn't patch the vulnerability. He took control over the server and he replaced all the PHP code in obfuscated code by his own. We analyzed some of it, but so for your question, he did not patch the vulnerabilities.
Yeah. Yes. We don't know. We don't know. It's one person. Actually, we think there is a crew of people. I agree with you.
Yeah.
Okay. Thank you very much for listening.